Hello. Hi, Joyce.
Hi.
All right. Uh, we'll wait for the other people for a few seconds, and we'll start at 7:10. Is that okay?
Yeah.
All right. Hello, Jasper. Hi, Jasper. We're just waiting for a few other people to join, and we'll start at 7:10. All right, guys. I think it's time for us to start. So, welcome to this week's Inland Empire Masterclass. And for this week, we're continuing we're continuing base number systems. It's base number systems part 2. So last week we talked about how to convert different bases to base 10 and vice versa. And this week we're going to talk about addition, subtraction, multiplication, and division for base numbers. To start off, let's have a short practice. What is 37562 base 9 converted to base 10? I'll give you guys a moment to think about it. And the hint is, instead of using powers of 10 when 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 solving these numbers, oh, we will be using base 10. So I'll give you guys a few seconds to think about it, and we'll reveal the answer shortly. All right. Do you guys want to share your answer to this question? Did anyone get the answer? You can type it in the chat. Not yet. Joyce said not yet. Do you guys want some more time? Okay. All right, Joyce, do you want to share your answer? You didn't get it? That's okay. I'll explain the answer to you. So the answer for this question is actually 25247. And why is that? Let me remind you guys of something. So instead of viewing the numbers and instead of viewing number by its individual digits, think about it as using the individual digits. So individual digits such as 2, timing the multiplying the base number to a power. So for the first number, for the first digit in a number, it's always multiplying by the base of power 0. So right here, for the first one, for the first digit, it has a 2, which means that it's 2 times 9 to the power of 0. Oh, hello, Kevin. So we're talking about base numbers this week, and we're talking about how to multiply and subtract them. Right now, we're just going over a review of how to convert base numbers, of what base number is, and how to convert base numbers in 9s, 2s, 3s to base 10, which is the base system we use normally. So for the first one, we have 2 times 9 to the power of 0 because it's the first digit. Now, Joyce, do you want to tell me what's 9 to the power of 0? Do you want to tell me does anyone know what's 9 to the power of 0? You can type it in the chat if you want to. Yes, Jasper said 1, and that is indeed correct. Congratulations, Jasper. So since 9 to the power of 0 is 1, this thing, 2 times 9 to the power of 0 becomes 2 times 1. After we got the result of what the first digit means, we then move on to the second, the third, the fourth, and the fifth digit, and we repeat this operation by multiplying each digit by 9 to the power of something. So on the second digit, it's 6, and because it's the second digit, we times it by 9 to the power of 1. That's how base numbers work. And so for this one, we'll get the result of 6 times 9 to the power of 1. So does anyone know what 6 times 9 to the power of 1 is? You can type it into the chat. Jasper said 51, and that is indeed correct. Excellent, Jasper. You're really good at math. So for the second one, we have 6 times 9 and 54. Oh, 54, my mistake. 54, not 51. It's 54. Got me there. So 6 times 9 is 54. And we just repeat the operation for the following numbers. And in the end, we add them all together. And that is 25. And that is 25,247. That's what 37,562 is in base 10 from base 9. Did you guys all understand this part? Think so? All right, let's move on to the more interesting parts and the real focus of this week. So for the real focus of this week, we are going to learn how to plus, minus, divide, and multiply different numbers. Let's go over how adding and subtracting base numbers work. When adding and subtracting base numbers, use the same operations as when you're dealing with normal numbers. However, there needs to be you need to be aware of two things. First of all, when adding numbers and one of the digits of the number is greater than or equal to the base, remember to add 1 to the next digit and subtract the base from the current digit. Secondly, when minusing base numbers and a digit being minused is smaller than the minusing digit, borrow 1 from the next digit. The next digit becomes base minus 1 instead of 9, what we do in standard subtractions. So this set of rules might be confusing at first sight, but I'll explain it. So the addition rules, let's use base 2 for this example. So to remind you, everything in base 2 has to be either 1 or 0. It can't be 2 because in base 2, everything has to be lower than 2. So say, for example, we're trying to find what's 10 plus 10 in base 2. We first do normal operations, just like how we do in base 10. We do the standard operations, and we get 0 and 2. Now, after we get this answer, we need to check if there's any digit that is greater than or equal to the base number. For 20, 2 is in fact equal to the base number. So what we need to do here is that we need to go on to the next digit, plus 1, and minus 2 from here, minus 2 on the current digit, which becomes 0 because 2 minus 2 is 0. So we get 100 from 10 plus 10 in base 2. Did you guys all catch that, or do you want more explanation? It seems pretty weird, right? Because how the heck does 10 plus 10 equals to 100? It's confusing, but think about it as think about the 100 not as an actual 100 in base 10, but the 100 in base 2. Because if we convert this to base 10, it's 1 times 2 to the second power plus 0 times 2 to the first power plus 0 times 2 to the 0th power, which gives us 4. And what's 10 in base 2? 10 in base 2 is 1 times 2 to the first power. So 10 to the base 2 equals 2. So this is 1 times 2 to the first power. Does anyone know what 1 times 2 to the first power is? Kevin He said 2, and that is right. So since 10 in base 2 equals to 1 times 2 to the first power, which equals to 2. So 2 of them will equal 4, right? Meaning that our operation is in fact correct, because 10 plus 10 in base 2 plus 10 in base 2 equals to 100 in base 2, what I did here. All right. All right, Jasper is asking, what did I say? So we're trying to see if 100 in base 2, which is okay, Jasper, I see you, which is we're trying to see if 100 in base 2 equals to 10 in base 2 plus 10 in base 2. So to see how, I'm going to repeat what I just did. We first do the operation in standard form, which gives us 20 in base 2. We all get that, right? Ten in base 2 plus 10 in base 2 is 20 in base 2. What? Jasper, can you stop spamming? Wait, sorry, what did you say? Can you guys hear me all right, or am I lagging?
No, you're good.
All right. So from center operations, we have 20 in base 2, right? But right now we have a 2 in the 10th digit, which is not good, because every number and every digit in base 2 has to be smaller or smaller than 2. It can't be even equal to 2. If it's equal to 2, we gotta do some transformation on it. So since there is a 2 here, we need to plus 1 and minus 2 on the current digit. Think about it as when you have 9, right? When you have 9 and you plus 1, what happens? Kevin, what happens when we plus 1 to 9?
It becomes 10.
All right, so it becomes 10, right? Stay with me. What happened here is that when you plus 1 to 9 in base 10, it becomes a number. When we're talking in base 10, we actually don't want to think about 10 as in the 10 we usually as in the 10 we usually have. You should think about it as 9 as wait, let me think how to explain this in more simpler terms. So the 10 itself is 1 in the 10th digit and 0 in the unit digit. There is no greater unit digit than 9, right? Right, guys? You can't have a one digit number greater than 9. That's true, right? Kevin? You can't have a single digit number greater than 9, right?
Sorry.
I was saying that you can't have a single digit that's greater than 9, right?
Yeah.
So because we can't have a single digit number that's greater than 9, we created the number 10, which is 1 in the 10th digit and 0 in the units digit. This number is created so we could count after 9 because 9 is the greatest single digit number in base 10. So let's think about the 20 here in the same way. In base 2, there can't be any digit that's larger than 2. 1 in this case is similar to 9 in base 10. What this means is that we can't have any number that's greater than 1 by the same logic that there can't be any number that's greater than 9 in base 10. So what happened when we plus 1 to 9, the biggest single digit number in base 10? It becomes 10, right? There is a unit increase because we have exceeded the maximum number that a single digit number can be. And this happened right here. 2 exceeded the maximum number of unit digit there can be. So it becomes 10 and the 0 stays. Did you guys all understood that? If you didn't understand, just type in the chat. All right, cool. So let's move on out since we all got the basic manipulations of adding base numbers. Yes, exactly. That's exactly right, Kevin. Because 2 cannot be achieved in base 2, right? It's like the biggest single digit number that can be in base 2 is 1. So you can think about 1 as in 9 in base 10. They're like the identical thing. They're identical because they're both the largest single unit number there can be in their system. So after you surpass 1, after you go over 1, you become normally in base 10 you would become 2, but that wouldn't happen in base 2 because base 1 is the largest single unit number. Therefore, like what happened in base 10, like what happened in base 10, you move on to the right with another unit. It becomes 1 unit larger, just like how 9 plus 1 is 10. 1 plus 1 in base 2 is also 10. Thus, we go from 20 to 100 in base 10. Isn't that just really cool? It's really cool, right? Because 10 plus 10 equals 100. That's when I first learned that, I was really, really amazed. And it's really interesting. So did you guys all understood what I said? Can we move on to doing some more complicated problems? All right. I hope you guys all understood what I just said. Let's move on to the next slide. So let's first practice by adding this number in base 8. Let's practice this. Remember what I said. You first add the numbers together, and then you see if there's any digit in the number that surpassed the base. If it surpassed the base, then add one to the following digit and minus the current digit by the base. So I'll give you guys Kevin said 1,109. That is really good, Kevin. That's the first step of solving this problem. But listen to what I said. 109 in base 8. Is that really?
The 9 is bigger than the 8, so we have to like move it.
Yes, think about what we said, and when we were dealing with base 2 numbers, we add 1 to the digit to the left, right? Because it's just like a 10, right?
Well, more like 2, because 1 minus 9 is 8, and it'd be equal to the base.
Yeah. So right here we have a 1, right? And this thing also becomes a 1. We can all agree on that, right?
Mm-hmm.
So we add 1 to the next digit, and we minus the base. So it's 9 minus 8, and we get 11111. That is a really cool number, right? It's 1 repeated 4 times, and we got this from this extremely unusual number, and it's really cool when you think about how much manipulations you have to do and how tricky it is. So Jasper asked, why did we add 1? So Jasper, I think you might have lagged off for a second when we were talking about numbers in base 2. So Jasper, if we have 1 in base 2 plus 1 in base 2, what do we get? 2. That's right, 2 in base 2. But remember that 2 cannot exist in base 2, because no matter what base you're dealing with, the largest single digit has to be smaller than the base. Think about it when we're dealing with base 10. Jasper, do you want to tell me what is the single largest digit in base 10? So a single digit number. What's the largest single digit number in base 10? Yes, that's really good, Jasper. It's 9, right? So what happens when we plus when we plus 1 to 9. It becomes 10, right? What really happened here was that since 9 is the largest single digit number that can exist in base 10, when we added a number, it has exceeded the largest possible single digit. So to continue the counting, we move on to 2 digits. So it becomes 10, which is 1 times 10 to the power of 1 plus 0 times 10 to the power of 0. And what's that, Jasper? It's 10, right? Good job, Kevin and Jasper. So the result is 10. So when we think about it, back to the base 2 example, 2 is just like 9 in base 10. I mean, no, sorry. Oh, Jasper is lagging again. But Jasper, can you hear me all right now? Or are you still lagging? Okay, let's explain this. So to the largest single unit number in any base is the base minus 1. So in base 10, the largest single unit number is 9. And that's because in base 10, 10 minus 1 equals to 9. And that's why the largest single unit number is 9. Do you guys understand that? So in 2, similarly, the largest single unit number can only be the base number minus 1. So it's 2 minus 1, which gives us 1. So 1 right here is just like 9. It's in base 2, 1 is the largest single unit number. So what happens when you plus 1 with 1 is that just like what happened in base 10, you cannot continue counting it by 2 because just think that in base 2, 2 does not exist. 2 does not exist as a single digit number. 1 is the largest single digit number. And by adding a further 1, we're breaking breaking the biggest number scale in base 2, which is 1. So to continue counting, we add 1 to the 10th unit. Did you guys all get that? Because we have exceeded the maximum amount of numbers that the largest amount that could be achieved with a single unit number. So that's why we moved on to 10. Jasper, Kevin, did you guys understood that?
Yeah.
Yeah? Okay, good. So with the base 8 example we had here, we get 1109 initially, right? But we have a problem right here. That is 9 is greater than 8. So remember what I said? 7 is the largest single unit number there can be in base 8. So what happens when we exceed 7? Kevin?
Yeah.
What happens when we exceed 7 in base 8? Think about what happens when we exceed 9 in base 10.
Well, it stays. Wait, they go past.
Yes.
Well, you can't do that, so you'd have to like move a number or something like that.
Yeah, it becomes 10, right? So
Mhm.
8 will become 10 because it's large. It's 1 unit larger than the single largest number, so it'll become 10. At the same time, we have to minus 8 from the single unit, the units this digit, because although we broke the largest scale of the single unit number, we still have to count from the single unit number if it did not reach 7. This part is a bit hard to understand, but think about it as when we have 10. When we have 10, when we have 10 and we want to continue counting, where do we add 1?
To the 0.
Yes, it becomes 11, right?
Mhm.
So when you think about 9, you can think about it as 8 plus 1. If 8 is equal to 10, then plussing 1 is the same as if we're plussing in base 10. We plus 1 onto the units digit because it's the smallest. Are we cool with that?
I guess.
Okay. Do you guys have any questions? All right. If we don't have any questions, let's move on to. Oh, by the way, Jasper, are you still lagging right now? Or did you see what I did for explaining the things? Okay. We'll move on to the next slide with some more challenging questions. Oh, this is just the explanation. This is the explanation in case you want it more visualized. But it's pretty much what we did. And we now move on to more practice problems. So let's try the first practice problem. I'll give you guys a minute to finish that. Feel free to type in a chat whenever you're done with the question. Kevin said 62 base 4. That is amazing. Sorry. Jasper said 62 base 4. That is, in fact, correct. You're absolutely amazing, Jasper. It's really cool that you could get the right answer in such a short time. Do you want to explain to us how you got the right answer? You could just unmute and start speaking.
Sorry, I'm a little laggy right now.
No problem. Yes, Jasper, I heard you, but you were a bit lagging. Do you want me to explain the problem? Sure, you can explain the problem. Okay, so Jasper typed in the chat that he got 56 when he added numbers together. That is right? Because 3 plus 2 is 5 and 3 plus 3 is 6. So we get 56. And Jasper is correct because 6 had exceeded the largest single unit number in base 4, which is 3. We have to add 1 to the 10th digit, which gives us 6. And at the same time, we also have to minus the base number from 6, which gives us 2. And that is, in fact, the correct answer for the first question. It's 62 in base 4. Did you guys all get that? Kevin, Joyce, Justin, did you guys all understood what I just explained? And great job, Jasper, for solving the question so fast. So should we move on now? Or do you guys still want me to explain? Do you guys still want me to explain the problem? All right, let's move on to the second question. What is 402 in base 5 plus 304 in base 5? Kevin said 711 base 5. Oh, that's really.
Jasper, no,
Oh, sorry. Sorry. I don't know why I got you guys' name mixed up. My bad. Jasper. Yeah, Jasper. Sorry, Kevin. Sorry, Jasper. And Jasper said 711 base 5. That is really near the correct answer, but there's one thing that went wrong. 711. Think about this number here. This is larger than 5, right? So what should you do? It's larger than 5. Jasper, take your time. 211. Again, that's really close, Jasper. Good job for solving this math problem, but there's still one thing you forgot. Do you want me to tell you the right answer? It's 1211. I think you forgot to add one here, right? Because you're supposed to add one when the thing exceeds. Right? Because you need to add one when one of the numbers exceed the base. But still, Jasper, that's really impressive. Good job for solving this question. The right answer is, in fact, 1211. And for those of you, Jasper, do you want to explain how you got to this conclusion? How you got this answer? Through the chat, maybe, if you're still a bit laggy. Explain the right answer. Jasper, do you want to explain the problem? Oh, okay. All right. So Jasper is saying that he first plus number together, which got 706. And in base 4. And because the 6 here is no, it's base 5. My bad. Base 5. Because the 6 here is greater than 5, we need to plus 1 right here. And because we plus 1 right here, we need to subtract 6 by 5, which gets us 11. And Jasper said he did the same thing for 7, which first you have to plus 1 in the next unit. And then the 7 turns into 7 minus 5, which is 2. So it's 1211 base 5. That's the final answer. Great job, Jasper. Now, let's work on the third problem. Feel free to type the answer in the chat. And for other people, I strongly encourage you guys to try solving these problems as well, because they're really fun. It's really interesting. Oh, okay. So Jasper said Jasper said it would be 3, 5, 2, 5, 3. And there's a immediate problem that you see. 5 is greater than base 4, so this can't be the right answer. Take your time, Jasper. Work through it more slowly. Yeah, 2 5s here. In base 4. And we need to do some manipulations to get the right answer. Jasper, you're confused. Do you want me to explain? Do you want me to reveal the answer, or do you want to solve it yourself? You're lazy. Okay. Let's solve this together then. So right here we have, so let's start off with the 5 in the 10th digit. What should we do for this one? Remember what happens if a number exceeds the base number? What do we do here? We add 1 to the following digit, right? It becomes, and at the same time, we need to minus this by the base number. So we get 3, 5, 3, 1, 3. But still, there's still another 5 right here. And it's in base 4. So it becomes 4, 1, 3, 1, 3 by using the same operations as before. But this one is a little bit tricky. 4 right here equals to 4, right? And remember, the rule says that the biggest number a base can have is the base minus 1. So the biggest number we can have is 3. 4 is larger than 3, so we'll have to do the same operations here. We plus 1 to the following digit, and we minus 4 on the current digit. 4 minus 4 is 0. So the answer is 1, 0, 1, 3, 1, 3. Yeah, that's some pretty big numbers. That's a lot of calculations. I don't blame you if you didn't solve it. But I don't think we have quite enough time to finish all of these problems. So let's work on problem 5 for our last question. This one is really challenging, and I'll be really impressed if you guys can solve this, because let me just remind you, for these alphabets right here, you might think, well, what are these alphabets? What do they mean? So when you go over a base, when you use a base that goes over, no, not quite variables, Jasper. When you go over a number with a base that's greater than 10, you're counting the single largest number becomes that base minus 1, right? So 12 minus 1 is 11. So 11 is now the biggest single digit number you can have. That's really, really crazy, right? Because 11, that's a 2-digit number. How is that a 1-digit number, right? Right, Jasper? That's a 2-digit number. There's 2 digits. So that's crazy, because how can you have a two-digit number as a largest single-digit number. So to solve this problem, computer scientists who tried to use bases that were larger than 10 used alphabets as single-digit numbers. So 10 became A. 11 became B. 12 became C. And each preceding numbers is the following number in the alphabet. And that's really interesting, right? Joyce is like, oh, Joyce got it. Jasper, do you understand now? So each of these letters are in fact representing a double-digit number. Okay, Jasper got it. So let's work on this question now. Let's work on this question. This one is pretty challenging because you're dealing with alphabets, right? I mean, who likes alphabets? I'll give you guys 2 minutes this time to solve this question. Jasper, I'll be really impressed if you can solve this question successfully. Just a quick question. Is number 4 10, 2, 3, 4 base 8? Okay, Jasper is curious about the solution to problem 4. Let's do it together. So by adding the numbers together, we get 4, 3, 2, 8. So this question is pretty easy. We only have to do one operation here. That is +1 and -8. So it becomes 1, 0, 2, 3, 4. And your answer is indeed correct, Jasper. Great work. I'm really impressed, Jasper. You're really good at math. I see a strong passion you have. Jasper, did you get the answer? Oh, okay, so A is 10. All right, so because we're running out of time, I'll leave this question as a take-home problem. You guys can solve this problem after class and tell me the right answer in the WeChat group chat. So that's the Inland Empire Math Circle for this week, and I hope you guys have a great weekend. Bye-bye.
Thank you.
No problem. Have a great weekend.